Welcome back to mini lecture number 3 with your host, Jess Vriesma. Today we'll be talking about bash scripts and environment variables. Before we begin, I'd like to give you a few self-check questions. Again, these are meant to help you review and see, are you ready for the content in this lecture? So go ahead, pause this video right now and see if you can answer these, and otherwise I will go on. So pause. Today in our mini lecture, we'll be talking about what is a shell script, how to write them yourself. I'll introduce a couple fancier features, and then we'll talk about environment variables. So first, what is a shell script? A shell script is a file that contains a bunch of commands that are to be run by a specified interpreter. So a shell script is a file, like a text file. It specifies what that interpreter will be, and then it has a bunch of commands written in a way that that interpreter will understand. Why do we have a shell script? Well, it's faster than writing in a bunch of commands over and over. So I could write the same 10 commands for bash over and over and over and over, but maybe it would be faster if I made a script that I just type in one command, the name of the script, and it will run those 10 commands for me over and over. Now there's a bunch of different interpreters that you could use for different kinds of shell scripts. You could have a Perl shell script, you could have a Python script, you could have a Ruby, Bash, Awk, or SH, often called shell script. SH is basically an older version of Bash. If you want to see some more examples of what these look like in different languages, you can see this link here. A bash script is a file containing a bunch of bash commands. That's what we'll be looking at and focusing on today. Again, there's lots of different other kinds of scripts, even a MATLAB script, but we'll be focusing on bash scripts specifically. Bash scripts can define functions, set variables, do looping. It has control statements like if, then else, or select case, or switch statements. It has a bunch of different functions that you can do. But you might be wondering, these are the kinds of things that a program does. So what are the difference between what are some of the differences and similarities between a shell script and a program? A script, first of all, is written in a scripting language. So the code, it is still code, but it's a sequence of statements or commands for a given program that would be interpreted by that shell or command line interpreter. A program is written in a programming language. The one place where you can have a little bit of each is you can have a Python script, but Python is also its own programming language. So you can have a Python program and a Python script. But most languages will be either one of these or the other. A script can be interpreted, or must be interpreted, not compiled by a certain program. And scripts will control that program via the different commands that are issued to it. A program, in contrast, has to be compiled. So if I were to type in, printf, hello world or whatever, in a C program, if I tried to run that C code, Bash would be like, hey, I don't know what this is. I can't run this C code. What are you trying to do? That's because a program needs to be compiled. So I need to compile my C code to a binary executable file, which will then become standalone. It doesn't need another program to run it, just the operating system. But a script needs to be interpreted by another program. Usually a script will be slower and a program will be faster. Scripts usually have a much smaller, more restricted purpose, but a program will generally be more flexible. Scripts and programs can both do I/O, input and output, user interaction, interaction with different files, creating, reading, writing them. They can do a lot of the same things, but a program is going to have a lot more capabilities. Typically, a script won't be opening windows. Programs, they can totally open windows. So a program is a bit more heavyweight and a lot more high performance. A script is more, here, I want to do something quick, and here's how I'll do it. I'll use a quick script. Those are some of the differences. So how do we write a bash script? Here's an example of a shell script. So there were many times when I was just typing too fast and I would accidentally type exig instead of exit. Now when I did that, the bash shell that I was running on would often say something like, error, exig not found. And I'd be like, ah, and it would stress me out. So instead what I did is I wrote a shell script called exig, this one right here, that instead of bash saying error, command not found, it would say, ooh, I found this command exig. This is a legit command. And then it would run the script. And instead of saying error, command not found, it would say, did you mean to type exit? And I would laugh at myself and I would type exit and I would go about my business. So let's digest this script. The first line of the script tells bash what program will interpret the script. The first two characters are known as the shebang, the pound sign or hashtag, followed by the exclamation point, which is often nicknamed the bang symbol, for whatever reason. So shebang, that's a keyword that tells bash, okay, this is the very first line of the file. This next little bit is going to be the program that you want to run to interpret the rest of the commands in this file. So the syntax is shebang, and then the name of the interpreter, the program, the path to the program that will run the script. Now you can also add some arguments after that. So I could be like shebang /bin /bash, which is where bash is found on many Linux computers, and then space, and then like, some command line arguments that I want to send to this bash. Because when you run a shell script, it's going to actually run a new instance of bash within the current instance of bash that you're running. So it's going to make a shell within a shell. It's going to run bash inside of bash. And this shell within a shell is going to be what's interpreting your program. Now, if you want a pretty quick tutorial that's really, really good, check out this tutorial right here. I'd encourage you to maybe just pause the video, type that into another tab of your browser right now, and then maybe resume the video, and afterwards, maybe go back to this tutorial and check it out. Just skim it. Now I have this awesome new script called exig, but how would I run it? You might think that I could just do /exig in the current directory where the script lives, and I would be able to run it like I would be able to run any other program. And you're kind of half right, but not quite. If you try that, it turns out you'll get an error. And that's because when we created this script, we created it in a text editor. It's a text file, and so by default, Vim or Emacs would give the script read-write permissions. In other words, I have the permission to read and write to this text file, but I don't have permission to execute this text file. Because why would I want to execute a text file? How would I do that? What does that even mean? Well, we know that this is not just any text file, but this is a shell script, so we can execute it. We can tell bash to run this script, to execute the script. Bash will spawn a new process, an interpreter, specified by the first line of this, so it'll spawn another instance of itself, and then that instance of bash, the child bash, will then interpret the commands in this script, in this text file. So I need to give execute permissions. So to do that, I can use the chmod command, which will change or modify the permissions of a file. I can do +x, meaning add executable permissions, and then /exig to specify the file that I'm changing the permissions of. So when you do that, then sure enough, you can run in bash like any other command. /exig, and you're good to go. Now, typically bash scripts use the extension .sh for shell, and that's kind of like .c or .java. It's just reminding us that this is what kind of script it is. If it were a Python script, I would have .py. So you can remove the extension in any of these shell scripts if you want, because ultimately the extension is not what determines what kind of file this is. It's a text file, and in Linux, files are often treated as either binary or text files by default. So this is a text file, but the important thing is that very first line, and that defines what kind of script this is. Because I've got /bin/bash as the interpreter, this is a bash script file. So let's talk about bash variables. If you want a more in-depth but an excellent introductory tutorial about bash variables, check out this link right here. I really recommend it. Seriously, check it out. Bash variables are similar to variables in any other language, but they'll be a little bit different because this is the Bash scripting language rather than, say, C or Java. So you can do two things with Bash variables, like you can for other languages. You can set the value of a variable. Now, if you do this, unlike C or Java, you don't need to initialize or declare a variable. You can just assign a variable. If that variable doesn't exist, it gets created. If that variable already exists, it gets assigned a new value. So you don't need to say something like int I equals 3. Instead, here in Bash, you could say something like I equals 3. And if I exists, now I has this new value 3. If it didn't exist, now there is a variable called I and it has value 3. Variables also do not have a type. The closest thing we can think of them as being is they're all strings. So there's no numeric value, there's no int, there's no boolean, there's no string or character. They're all just strings. But Bash does allow numerical comparisons if a variable has only digits. So there's a couple special cases, but generally variables don't have a type. So here's some examples of setting the value of a variable. You can create a new variable called foo and assign it equal to hello. The quotation marks are optional. They have some special syntactical features that we can talk about later, but you can have the quotes there or not. So bar equals 2. Again, 2 is going to be a character 2. For a string, it's not going to be the number 2, though you and I might think it is, and we might want it to be that. You can also have directories, so I could have my directory or my dir equals ~new_dir, some file called new_dir in my home directory. Again, they're all strings. The other thing you can do with a bash variable is to get its value, or reference its value. To do that, you put a $sign in front of the variable's name. Now, doing that, so for instance in this example here, you've got a variable called foo, and you put a $sign in front of it, and that will resolve into the value or whatever is inside of that variable. That's a shorter form of $, curly brace, foo, end curly brace, which is the full syntactical version. Most of the time you'll just see the shorter version, $foo. So for example, you can have foo2 equals $foo. It's just copying the value of foo into foo2. You could also, if you want to print out what the value of a variable is, you could do echo, which prints out something to the screen, and then you could either have $bar or $curly braces bar. Either one will work. Single and double quotation marks in Bash are slightly different syntactically. Single quotation marks will treat all the characters in between them literally, as a string literal. So suppose I want to output the value of a variable called foo. So I set foo equal to hello, and then I echo the value of foo. So echo, quote, $foo, end quote. But if I do that, it's going to, again, it's treating the $foo as text literals. It's not saying that's a variable, it's saying this is all text, and I'm going to output just that text. So it's going to output $foo rather than hello. If I want to get the value of foo, I would have to use double quotation marks, and that will allow variable substitution. So again, I set foo equal to hello, and then I echo double quote $foo, double quote. And now it will take in between those two quotes, it'll take $foo, it will resolve that back into whatever the value of foo is, and it will output that to the screen. So it'll output hello. If you want, you can try this on your own. You don't need to even do a script for it. You can just try opening up Bash and copy those commands and see how they work. In Bash, spaces matter. That's because Bash uses spaces to separate words. And different words could be different command line arguments. They could also be different commands. So whitespace does matter in Bash to a certain extent. So for example, I could have my program, some program that I wrote, and then hello and then world. Now if I do this in Bash, Bash will treat the first, it'll separate this whole string that I've typed in into 3 different words separated by the whitespace. It'll assume that the first one is a command, my program, and then it will assume all the others are arguments to that first command. So here, my program is the command, hello is the first argument, and world is the second command line argument. If instead I surrounded hello world with double quotes or single quotes, then it would treat that all as one word. So my program would be the command that it would run, and then it would see hello world as the first argument altogether. Now you saw an example of this in Lab 7. Now what's up with the $? That's kind of funky. The $? Is used for referencing a variable, like we saw. So foo can be set to the value of bar, foo can be set to the value of itself, foo can be set to the value of itself a different way, using the curly braces. But you can also set a variable equal to the output of a given command. So for instance, say I want to store in a variable all of the different files that are in the current directory. So I'm going to create a variable called files in the current directory, and I'm going to set it equal to the output of the ls command, which runs in a subshell, and it will output all the names of the files in the current directory. You can do that using $ and then parentheses. Kind of cool, and sometimes it's very useful. Now there are some special bash variables as well. These come up often. $, pound sign, or $hashtag is the number of command line arguments passed to the script. So this is a special bash variable, and it acts just like argc in the C programming language. However, whereas argc will give you the number of command line arguments plus the program name, the $hashtag here in bash will give you that -1. It doesn't count the program name or the script name. It only counts the extra command line arguments that get passed. $0 is the 0th command line argument, and this is just like argv in C, argv0 that is. So this would be the script's name as the user invoked it. $1, $2, $3, and so on are the first, second, third, and so on command line arguments that are given to the current script. And this acts just like argv1 and argv2, argv3, etc. in C. So this is pretty handy. Now, if you run a command and you want to know if that command was successful or not, make a new directory. Did that directory actually get made? You can query the exit status of the last process to run. That's stored in this special variable, $? So if you want to know, you can just see what the value of this variable is. If it's 0, then there's no error. If it's anything other than 0, then there could be an error. You can also print out the line number of the current line in a script. So say on line 45, you say echo, error on line, and then you could use this variable here, $line no. That would tell you where in the script that error happened. So that can be very useful for debugging. And I really wish that this functionality existed on more programming languages. So if you want to know a little bit more about different kinds of variables, how to work with them, a little bit more about these special variables, and to see some more examples of them, I'd encourage you to check out this tutorial. And again, I don't expect you to know everything in all of these tutorials, but I would encourage you to, for every one of these mini lectures, check out one or maybe two of them and consider them a sort of assigned reading assignment. So here's an example of a more complicated shell script. Don't worry about what's going on here yet. Let's just look on the right side. What is this script doing? This script prints out a bunch of lines to standard out. And why? Sometimes I like to clear the screen, so I could just use clear to clear the screen. But maybe I don't want to clear it entirely. Maybe I just want like 5 lines of empty space. So what I could do is I could just hit enter 5 times. But then it has my prompt there. Maybe I just want 5 empty lines. So I made this command make space. This script will do that. So again, if you look at the syntax, you can kind of imagine, you can kind of see maybe a little bit of what's going on. There's an if, then, an elif, which is else if. There's an else. There's a weird fi going down. and then there's like a for loop, a for, do, done kind of thing. Let's break this down a little bit. So let's try to understand what's happening in the script in a little bit more detail. So the very first line is saying shebang /bin /bash. We want bash to read this, this script. The next two lines are starting with the pound sign, which is the comment character. So those two lines are comments in bash. The next line is if square bracket $, pound sign, dash equals 0, end square bracket. That is an if statement that's saying, does the number of command line arguments equal 0? If it does, then that little bit resolves to true, and then we set the number of lines equal to 0. So numLines is a variable. It didn't exist anywhere else in the script before, so we're declaring it or initializing it right now. And we're saying if there's no command lines given, then we're going to have the number of lines be equal to 20 by default. Else if, the next line is elif, else if, and then we have is the number of lines, or the number of command line arguments equals 1, then set the number of lines equal to that argument. So if there's no command line arguments given, let the number of lines that we're going to print out from the script be 20 by default. But if there is a command line argument, then we're going to let the number of lines equal that number of lines that's specified as the first argument. Else, if there's like 2, 3, or 4 command line arguments given, then we're going to, that's an error. Like we could just ignore those extra ones, but we're going to actually have an error and say else echo, so we're going to print to the screen a usage statement. Usage $0, meaning the script name, and then the number of lines, default is 20. And then exit 1 saying that we exited with an error. This didn't really quite work as intended. So now we should have number of lines equal 20 or whatever the user told us in the script. So the last 4 lines are a for loop, and it's saying for I equals 1, I is less than equal to number of lines, and I plus plus. So that's the signature of a for loop. Looks kind of similar to what we would see normally. Again, we haven't initialized, or we haven't declared I previously as like an integer. We just create a new variable I, and it's going to be a string, but bash is going to be smart and treat it like a number. And then we have do and then done. Notice again that there's no special curly braces for the do loop like we have in C or Java, but we do have do and done. Do says this is the beginning of the block of code, and done says this is the end of the block of code. You can also put the do on the same line as the for, but you'd have to have a semicolon after the double parentheses bit, separating the for part from the do part. And then we have just in the middle an empty echo statement, meaning print a blank line. So this is going to print as many blank lines as the user specifies, and if they don't specify anything, it will print out 20 blank lines. An if statement looks like the following. If, and then the square brackets, $, pound sign equals 0. Notice you have the square brackets, and that's going to be what resolves to either true or false. Notice also you have then or else on separate lines. You don't have curly braces at all. You have the if statement on one line, and then you have the thens, elfs, the thens and the elses, and then the elif on separate lines. You could put the then on the same line as the if, but you would need a semicolon after the second square bracket. And then notice too that you have if at the very beginning of the if statement, and then you have an fi, which is just backwards if, at the very end, and that denotes the end of an if block. Now in C and Java, you can just have a single line if statement, so if this, then that, without the curly braces. Here you need to have the if, the then, and then the fi at the very minimum. The for loop again looks like this. You have double parentheses. You have the counting variables, just as like pretty similar to like what it looks like in C or Java, except you have the variable with the $sign again. And again, you're not initializing I. I is a variable, and in Bash, you don't need to initialize, or you don't need to declare your variables ahead of time as an integer or unsigned or whatever. Again, the do statement can be on the same line as for, but you'll have to have a semicolon after the double parentheses, which tells bash, actually this is a separate line. And then done completes the block of code in the for loop. Let's talk now about environment variables. What are environment variables? Environment variables are certain kinds of variables that affect the way that commands are run in a command line environment, like bash. Now, environment variables are included, and they're pretty important, in all Linux flavors, as well as in Mac OS. Now, the Windows operating system has also started to use environment variables as well. Previously, Windows used things like the registry to say, here is a variable and it has a value, and that will persist throughout everything. Now they're starting to use environment variables the same way that Mac and Linux use them, though a little bit different. You can think of an environment variable as being like a setting for a shell session. Each shell session will have its own environment variables, its own settings. They're identical in how you use them and how you set them to regular variables in bash. So what's different? Well, if I create a shell script, it will load some existing predefined variables, that is the environment variables, into my script. So I could access those variables from my script without having ever defined them. They're already predefined. So when I create a subprocess in a shell, it will pass the environment variables from that parent shell into the child or the subprocess. So if I run a script, if I start a bash and then I run a script, then all the environment variables from bash, the one that I'm running, will get passed into the version of bash that runs my shell, which is bash within a bash. So what can you do with environment variables? Well, you can set the environment variable's value, just like a regular bash variable. So here are some examples of common environment variables. There is editor, which in this case is preset, at least for my system, to /user/bin/vim. So some programs will actually ask me to edit a file, and so if they do, that program might find out what editor I prefer, and so it would look at this environment variable and then open up that. Maybe you would want that to be Emacs instead. There's another environment variable called hist size. How many lines of history do I want to print out and keep track of when in a bash session? And there's also the path variable, environment variable, and this is arguably the most important. This is the variable that bash checks to find out where commands might be. So if you type in a command, bash says, okay, that command isn't found right now. Where should I find it? It looks at the path variable to see where are all the folders where all commands are stored, and does this command that just typed in live in any of those directories? So you can get an environment variable's value as shown there. You can echo the value of editor. You can echo hist size to see how many lines I want to keep track of. You can also echo the path. And I'd encourage you to try this to see what your settings are for your system. So go ahead, pause it, try it, and then come back. Again, bash variables are environment variables. Environment variables are special types of bash variables that are just predefined. They're the background variables that exist already whenever bash runs. Okay, and again, because of the quotation marks, because of the way I've done, $editor versus $parentheses editor, those things might do things slightly differently, but that's more advanced bash stuff. You don't need to worry about that usually. So let's take a look at the path variable. We said that that's related to how bash finds commands. So how does bash know where to find a command you type in? So if I type in GCC, how does it know where the GCC command lives? There's no like programs directory or applications directory. It looks at the path environment variable. So the path variable is a colon-separated list of directories that look like this. So if I do echo path, it might give me this for the thing servers. So here I have a directory called /user/local/bin, another directory called /user/bin, another one called /user/local/sbin, and then another one /user/sbin. So those are 4 different directories that bash will look in if I type a command. Now there's actually one or two other directories that it might look in as well, but those are ones that it's going to try to look in first. So if I type in a command, then bash will look in those directories, starting with the first, to try to find each command that I type in. And then if whichever one it finds first, it will run that one first. Now, if you want to see, there's a lot of computers that will have different versions. They might have different versions of GCC. They might have different versions of bash. And how do you know which one is going to automatically get run when you type, say, GCC? You could use the which command. So which GCC is going to tell you where in your computer system GCC lives, so that when you type in GCC, that's the one that gets run. So that can be useful if you're like, well, what version of GCC do I have? Where is it living? And so on. You can check that out. So here's a quick warning. When you execute a bash script, it runs the script in a separate subshell specified by the first line of the script. So again, shebang/bin/bash is going to run a subshell of bash within your current session of bash. So if I do /myscript.sh, it's going to run a separate version of bash within my current shell to run that script. And if I set a variable in that script, then that variable is going to get set for that subshell, the bash within a bash, but that variable is not going to get set for the parent shell. So as soon as that script's done, any extra variables that script set are going to go back to whatever they were in my current shell. They're going to disappear. Just like with scope in a function, if you define a variable in a function, then as soon as that function is done and it returns, then all the variables in that function go out of scope. Similar thing here. So if you want to run a script from the parent shell rather than in the subshell, you can do the following. So for instance, say I want to have a script that sets a whole bunch of different environment variables for the current bash shell. I can do that using source. So if I do source myscript.sh, it will run all of those commands in the current bash process. And if I do that, then all of those variables that get set will still be around. This is exactly as if I had typed them all in one by one by hand. And that can be useful for some things. So here are some tips. First one, use echo often when you're writing a shell script in order to check the values of the variables in your script. Same as when you're programming. Use an output statement to see, are things what they should be? This is especially true for bash scripts because sometimes the syntax is a little bit trickier to understand. Also, string and numeric comparisons are different. I'd encourage you to check out how to do that exactly. If you want to do a number comparison, for instance, in an if statement, you can do it like this. If, and then your variable called number equals 3, for example. But if you wanted to compare a string to another string, you should first of all surround them in double quotes, and then you can say if my variable called text equals, say for instance, message, whatever that message might be. This is how you would do it for a string comparison. And here you're using the double equal sign, whereas before you're using dash equal. Another tip is to always use comments in your scripts. Comment more than you think. For shell scripts, comment more than you would for a normal program. And also, if you're making I say especially for a header file, I meant especially a header comment. So include your name, the date, what this script does, because sometimes it can be a little bit harder to trace. I also encourage you to try to write 2 or 3 of your own scripts to do fun or useful things, just for practice for this. So what maybe 3 or 4 commands do you find yourself typing in over and over and over again in the same order as you program or as you develop code? Maybe what you could do is you could create a script that will do some of that for you. So for instance, if you're compiling code, and rather than typing all that stuff in, like say you have like 2 or 3 or 4 files that you have to compile, rather than saying compile file A, compile file B, compile file C, instead what you could do is you could write a script that compiles all 4 of them one after the other. and then you just say run the script, and it compiles all 4 of them. Now soon we'll be learning about makefiles that do this in a much, much better way, but for now, this is a nice handy thing that you can do, and it's useful. What I do is I created a directory in my home directory for my scripts, and then I add that directory to the path variable in my bash rc. That way, if I have a whole bunch of scripts, like the exig script from the beginning of this, this mini lecture, or the makespace script from the middle of this lecture, I put those in this scripts directory in my home directory, and then I can access that that scripts directory and those commands from anywhere on the computer system, no matter where I am. Because again, if you put that directory in the path variable, then bash knows where to find those commands. So that's it for this lecture. I have some review questions here. I encourage you to pause this and check each one of these, see if you can answer them. If you can't, rewind, rewatch, and see if you can figure it out. If you have questions, please do email me. And then I also have a practice problem for you. So I encourage you to try writing a bash script that takes a number as an argument and outputs all the numbers from 0 to that number. And as a bonus, if you can do that, try adding code that will check how many input arguments there are. If there aren't exactly 2 arguments, the script's name and the number to count down from, if there aren't exactly 1 argument, that's a typo. So if there's not 1 extra argument, the number to count down from, print a usage statement and exit. And as a hint, pause here. Pause unless you really need the hint. Try it first, and if you can't get it, here's a hint for you. 3, 2, 1. The example script in the gray box on an earlier slide from the makespace program is very similar to this problem. In that one, it would just output empty lines, but in your example, you would want to actually output the number, counting from 0 to that number. All right, that's it. Thank you guys so much for your time, and I hope you have a great rest of your day. Stay safe, stay healthy, and stay awesome. Bye-bye.